Welcome back to Thrifty Tool Shed. Today I thought we'd look at capacitors, some of the safety features of capacitors as far as discharging them, checking the ESR or equivalent series resistance of capacitors, since that's very important in a circuit, especially power supplies, high frequency applications. We're going to start off looking at the YOSOO GM328. The cheapest out of the group today we're going to test. I did a full review of this in one of my previous videos. If you hadn't seen it, you might want to look at it, or at least parts of it. Sums up a lot of the operation. I'm not going to go over it in detail today, but I am going to use it for capacitance and ESR and for comparison. I also have a little Signstek, the MESR100. It's the version 1, not the version 2. But I hadn't been real long about it, but the version 2 is a little better. I'll talk about that a little bit. This is just an ESR meter. It does not do capacitance, ESR only. You can actually buy the capacitance checker as well. The Peak, the ESR60, and the BK Precision, the 879B. Have a look at it. This is an LCR meter, a lot more functionality built into this one, but we'll just use it as a comparison and checking capacitors and ESR. So we'll have a look at them one by one. I'll start off with a quick look at the GM328. I won't bore you with the details of this one, since I've already done a comprehensive video on a lot of the functionality that I figured out about it. So it doesn't come with a lot of literature. It pretty much comes in the box like it is without the back plate. I added that, as I mentioned on the video. But it does do a really good job with capacitance and ESR, so I wanted to include it in this test today. This overview look of the meter today. The Signstek MESR100. This is the version 1. They got the version 2 out now. Comes with a little manual. Shows that it used 100 kilohertz for testing. Let's power it up. It does have a backlight. It's pretty decent. This one also has a backlight, which I didn't mention because it's actually a pretty nice backlight. Put the leads together. So it'll let you know the range, and it's in auto, and the ESR value, whether it's good for 25 volt rated reference, and also gives you a comparison chart below, which is pretty handy to have right on the meter. A lot of those charts are generic. You'd have to look at the caps information directly. Yeah, you would have to just look at the like the spec for the capacitor manufacturer itself, whether it be Rubicon, or you just have to get the information off the actual cap and look up the data on the data sheet or reference sheet on the cap itself, because ESR values do differ from manufacturer or even their series of caps, because some capacitors are very good, low ESR capacitors, especially for higher end applications, high frequency applications, should I say. The manual is really good with the Atlas ESR60. Comes in a nice little box. I already cut it on here by accident. It's okay. This was the only one that we have that does not have a backlight, but I can honestly say that I never really needed it. It's got a really nice bright green back into the LCD, so never really needed it. And the resistance measurement's always pretty accurate with this one. It does, like I say, capacitance and the equivalent series resistance. And last but not least, the BK Precision. Comes with the leads, the meter, a USB cable, and this one will communicate with a PC. Base the driver you can download from the internet. Also comes with an AC adapter, so you're not just relying on a battery if you're on the bench testing a lot. So that's kind of handy. To mention a little bit about price here, I have them in order from least to the most expensive. As of right now on Amazon, you can get the GM328 for under $20. $19.49 was the last price that I've seen on it. The MESR100 comes in a lot of different name brands. This one's Signstek. At least a lot of them look similar packaging, even down to the chart table, ESR table on the front of the meter. But like I say, version 2 is available now with a little more features, but around $55 is the going price on these. It does have the 100 kilohertz to help remove the impedance off the capacitor when checking the ESR. It also uses the square wave. Now that they say that the version 2 uses a sine wave to give a little bit better testing. It's supposed to have a resolution down to 0.001 ohm. It does the auto display for the bad caps or good cap, based on a common 25 volt electrolytic cap. This one uses a 9 volt, but the version 2 uses 2 AA's. And I think the version 2 can also be USB powered, which this one has it as well. The Peak ESR60 is actually becoming obsolete now. They have the 70 model out, which looks almost identical, but this one sells for about $119 if you can still find it. I believe the ESR70 is still selling for about the same price, like I say, with a little bit better features on it. The 879B is selling for about $299. I think Amazon has it for maybe $263. But it's by far the most expensive. But I won't really get into the complete comparison of it or review of it even, because it's an LCR meter and it has a lot more functionality than what we're going to get into today. Just checking, I just want to stick with strictly capacitance and ESR on an ESR meter. For checking things like switch mode power supplies and other high frequency applications, ESR is very important, and it's an easy check. Sometimes if it's borderline, I don't so much worry about a cap, but this is one of the better charts I've seen, and I use it a lot to go by. And I didn't realize it till I bought the Peak that this chart's actually in the booklet. Whether they originated or not, I just use this generic chart, I don't know. But it's the exact same chart and wording in the actual book that comes with the Atlas ESR. So a little bit of quick rundown. Of course, this one has already been mentioned. That the previous video on this one already tells a lot of detail about it. I'll go into this Peak because it has a lot of features as far as the 100 kilohertz capacitance and equivalent series resistance check. It's got the automatic discharge, this is the only one that actually has that. But it does ask that it's less than 50 volts. If the capacitor is greater than 50 volts, then it will let you know on the screen, on the automatic analysis. It'll let you know that capacitor is greater than 50 volts, or will show you the voltage readout on the screen, and it will ask you to discharge it properly. The leads on this little meter are very good. Even though it's a little bit of a specialty, you can get replacement clips, and it looks to be gold plated. And whenever you short these out and do a check, it always shows 0. I mean, it really does a good job on the low ohm scale. On the 60, the maximum resistance it'll do is 20 ohms. Now the 70 is 40 ohms. So the one that's available now will go up to 40 ohms. And just to mention, the 60 don't have the audible alerts. The 70 has audible alerts to let you know. And I thought that would be a really neat feature. If I ever get a 70, I think I'll enjoy that, because just going through checking, maybe on a circuit board, just going through checking different caps, it'll actually have a different tone of what range the ESR is. So you can possibly go across a circuit board and not even have to look back up until you hear a different tone or beat, or maybe you don't hear anything at all, like it's not reading anything. So I think that's a really good feature. The capacity range on this one is 1 microfarad to 22,000. And it does really good for capacitance and low ohm checks, which actually all these ESR meters will do that. It does have the auto power off. It does take a little 12 volt alkaline battery, the little the 23A type. And it is polarity free. This one and the GM328 are polarity free. You just plug it up or hook it up to the capacitor. Either way, it'll read properly. These two actually want you to do the polarity correctly on these. As far as the 879B, it has a lot of configurable capabilities, from beep, auto off, default modes that it comes on to. It also has the backlight. The LCD is really good on this meter. The case is really good quality. I do really like BK Precision stuff. I got a little meter here. I know it's a different subject, but they make similar things. I like the little toolkit, the little 2709B. It's got the little magnetic hanger. And I just kind of keep it hanging up on my bench. It's the one I have my tweezers hooked to for some of the circuit board probing. It's a good little meter. It's a true RMS. I have no issues with it. This meter is made very similar as far as the case. It has the USB capability to download the driver. It can be powered by the wall adapter. And it states to generally test like the 1 kilohertz test for 0.01 microfarad or smaller. And when you get above 10 microfarad, it wants you to use the lower, like 120 hertz frequency, which seems a little unusual to me. I know that typically 100 kilohertz is what manufacturers test their ESR. That's a typical thing, not across the board, but you can also select, besides the frequency selection, you can check and change. This one only goes up to 10 kilohertz from 100 hertz, and it steps up to 10 kilohertz. This one, like I said, does not do 100 kilohertz. The 880 model that they make will, but I think it's $399. So to me, that's a lot of money for a meter, but somebody uses it every day. to have that much functionality, it's probably worth it. It defaults on power up. It defaults to parallel and 1 kilohertz for the check. And we can hold this button down from P to S. It'll go to SCR for series. And we can go frequency up 1 to 10. It'll go down to 100. 100 hertz, 120, 1 kilohertz, 10 kilohertz. So this one has a lot of functionality, a lot of different ways to check ESR and capacitance values, which sometimes can be a little confusing. It comes up by default in the parallel mode, and it actually checked, I think it checked capacitance better as we get into it. I think it checked capacitance better typically in parallel mode, but in series mode it seemed to show a truer ESR. So we'll look at that a little more as we get into it. But this one also does not have a discharge, auto discharge. It tells you to discharge your capacitor before testing. So we'll look at now, we'll go through a few tests with these and compare them. As a safety precaution, we're going to be dealing with some very large and very powerful capacitors. This one in particular is 22 microfarad at 450 volts rated, so a lot of charge. It's a pretty heavy capacitor, and even this one, it may look small in comparison, but it's a 560 microfarad at 200 volts, so it's also a high rated capacitor. So what I'm going to do is charge it up with instead of my power supply, I have this 56 volt battery that's fully charged, that'll charge it up very quickly. I have a 470 ohm resistor with some leads, and these leads have a little resistance too. They're not the best quality. Actually works out pretty good for discharging capacitors. If we want to charge this up, always when charging a capacitor, you want to keep your polarity correct. If you don't, it can blow up in your hand, your face. It's a quick charge there, straight on, straight across. So this capacitor close to a lethal level now. We cut it on, immediately it says 52 volts, please discharge, or capacitor, and now it went down enough that it's actually discharging automatically. Discharged it and tested it just that quick. This meter is really good at doing that. But I always be very, very careful and make sure your capacitors, you know, the method of taking and running a screwdriver across it, it works well to make sure that it doesn't have enough charge to hurt you. Heat rather to arc than hurt you. But also, I'm gonna charge this one up and it's gonna arc too. Now even charging this thing up at that level, which is a 450 volt now, but and it's saying it's 55 volts, safely discharge it. So it's letting you know, it warns you. Lets you know that it can't discharge it at that level safely. So at this point we can take our resistor and leads and we can discharge it. Make sure you can see the meter there. And it is discharged. This time I have this large capacitor charged up again. I want you to be able to see the voltage on the screen. And by taking the resistor and a jumper and going across I want you to be able to see how slowly it discharges. It's rapid enough to discharge quickly, but yet it doesn't do it in a high rate, in an arc. Because honestly, with this capacitor at 450 volts charge, I would not want to discharge it straight across with a bus. So we'll demonstrate that with just 56 volts on it. It's pretty big bang. So once again, we got this large capacitor charged up to, it's right at 55 volts on it. 55 volts at 2200 microfarad is fairly large, but it's nothing compared to the 450 volts. So it's a pretty big pop, so enough to scare you. So that way, by using a resistor, it can be a little less intense, but nonetheless, at least just use a screwdriver or a jumper to make sure they are totally discharged before moving forward, because some of these can be at lethal voltages. Most circuits, if they're in circuit, most of them do have a bleed resistor, which you can't always rely on that. They could be faulty as well, and you can't always rely that they actually have one in circuit either. So always rather safe than sorry. Not only for your sake, but also the meters, because not all of them have the safety built in as the Peak does. So always keep that in mind. Once again, I have these capacitors charged up to about 55, 56 volts, discharging straight across the terminals. This 560 microfarad at 200 volt, also charged up to about 56 volts. So that's the difference in putting a resistor across, or if it's below 50 volts, just letting that discharge it. So again, if this was charged up to a true 450 volt potential, it would take a chunk out of the screwdriver shank. So just always be aware of what you have in comparison to, they are both, or all are electrolytic, but there's a big difference between this little small one and of course the larger variety. Okay, so one thing to remember about capacitor, well actually two things to remember about capacitor and ESR check-in is, the first thing, safety. We covered that. Cover yourself. Make sure your capacitors discharge. They can harm you, especially the larger variety that can go up to 450 volts at high capacity. But anything over 50 volts can be deadly, so be careful. The next thing to really consider when you're doing ESR testing is think about the low resistance of the test. What you're checking is ultra low or very low ohms, so the resistance does matter. So if we use this GM328, we can very easily put some clips in here in the little ZIF socket and close it up, so it makes it real handy, right? Well, for some things, the reason this ZIF socket is so important is it's very low ohms to the trace, so it's designed to be as close as you can, especially ESR or low ohms reading. If we were to short this out and do a test right now, it's one of the best ways to do this. 1 to 3 is showing a resistance of 1.33 ohms. Now I did that just to show that how crappy some leads can be. It's that these little cheap, like eBay leads are just that much resistance, and it's a really crappy connection. We can remedy some of that, but just to show the little crimped on, folded back, not even soldered. So just be careful what you do with leads. This is probably an exaggerated case because the leads are such poor quality, but it just goes to show that it does matter, because what we're checking for is down. Some of these capacitors, the larger they get, like 0.01 ohms, so you can see we already out of spec. For an example, I'll just use this one for an example. Let's say 2,200 microfarad at 16 volts. Put it on here with these leads. Let's see what our ESR test tells us. Checking the capacitance. Capacitance checks good, which, you know, through the resistance in the wire, the capacitance show up okay typically, just a little bit lower. But 0.75 ohm, that's pretty bad. If we look at the chart here at 16 volts, we should be at 0.07. So is this a bad cap? Well, let's do the same test this time. Putting it across the ZIF socket directly. And 0.11, so it's really close. So according to this, we're still a little bit higher. Sorry, we're still a little bit higher than it should be. But I think the capacitor's okay. It's not showing a tremendous variance from the typical chart. And at that point, if it really matters to you, I would look up the actual manufacturer and see at 100 kilohertz what it actually, the manufacturer states the specs for that capacitor should be. So with that being said, this little capacitor little tester does do a good job with capacitance and ESR. Just always keep in mind it matters about leads, which is also one reason all these meters come with little short leads. Even this high dollar meter has got some pretty short leads. And these are a little longer, but they are high quality, really high quality leads, and they do work well. But we always have to zero out our meter, and we have to make sure that the leads are as short as possible doing the 100 kilohertz check for ESR. Okay, now we're back with the GM328. I got a few capacitors here to check. I had a bunch more up here and even some more back in the back of the bench to check. I realized it was going to take a lot of time. I didn't want to bore you to death through the video. Try to keep it as short as we can, so I got 4 capacitors up here. One of them I know is a failed capacitor. I didn't actually keep many from repair jobs, but I did actually have this one. You can see the very typical bulge and the swell factor of this capacitor. It was a good name brand and a good style capacitor. Just over time, it's actually over 20 years old, so just time for it. They don't have a very long life, electrolytics. So we'll check these 4, one known bad one. And then I also wanted to take time to get into we'll do some in circuit just on a board that I have. Got a large cap here. We got some, I'll probably at least check this one here on board. Got a little stepper driver here. Probably check this big cap here. It's one of them that during my move, it got dented up. We'll check it and see, hey, is it still okay? Check okay, or especially if it doesn't show short or anything like that. So we'll get into testing with this GM328 first. I got the large 2200 microfarad, 450 volt capacitor. I'm gonna cut this bench light off. I believe it'll be better. The glare on the screen. Well, first of all, let me zero out the leads here, or at least show you what it is. We can go through a we can go through a procedure and actually 0.07. So you can go through and self-test and zero out the leads wherever they are, that it go through a calibration check. But we know with 0.07 or 0.08 is what I read earlier. I wrote that down. And we're getting 0.15. 0.15, 2012 microfarad. Okay, wrote that down. Let's go on to the next one. This is the 560 microfarad, 200 volt. And it's showing 0.48. Let me check that again. .15. That's what I got earlier. I think I had a bad connection on the. It does matter. They got to really. The leads need to be on there good and tight. If you're talking about less than an ohm value, it don't take much to change the reading. Yeah, 0.14. That's more like what I was getting earlier when I checked it. All right, now this was the one that's known defective. One of the tests here is, will all the meters pick up the good ones being close to intolerance, and will it pick up the bad one being defective? And we're showing a 1274 nanofarad, and look at that, as 0.14 k ohm, not 0.14, so voltage loss of 23%. So we're showing this 250 volt 22 microfarad isn't showing almost any capacitance where it should be, and then the resistance is showing way high. So some of these meters won't even read that high. So it picked up the defective one, definitely picked it up as defective. We have a 6800 microfarad at 35 volts. .10 at 8313. This one actually reads high by all the meters. Next, we'll try to do an in-circuit check. These leads do have some loss, but it's not real bad. It's 0.07 relative. All right, so we have a 2514 at 0.11. We'll also check this one up here. See that larger one, easier to get to on the edge of the board? I think you can see that okay. Hopefully these will make a good connection. You can also go into this meter, and we can hold it down and go into setup mode. Keep hitting the button until we come down to ESR, capacitor plus ESR. That's on 1 and 3 though. I may have to change my, hold it down. I think I'll have to change my, I think I got it on 1 and 2. There we go. So if you can see that, when it's on this mode, you can actually just clip it to something. It actually is self, like auto detect, if you will, self detect. Start showing the capacitance and the series resistance on the screen. So that way you can do it hands free. Hope you can see this on camera, sorry. There we go, we got 48 microfarad and 0.99 to 0.98 ohms. And this is a 47 microfarad. Can you see that okay? Nope. It's a 47 microfarad at 63 volts. It's a 85C rated capacitor, so it's not the highest quality or highest end capacitor. For example, this one, I didn't mention that, but this one is 105C. It's right on the top there, 105C. Typically, your higher switching capacity and like lower ESR capacitors are rated for that higher temperature. We got one more here to check in circuit. A 8200 microfarad at 50 working volts, and it's showing 8.15 millifarad or 8150 microfarad at 0.08 or 0.1 ohm. I typically use the ZIF socket on 9% of the test if I can on this meter, so something similar to this, a plug right in. But I mentioned in a previous video about this that you can solder your own leads on to get a better connection, and even going through the calibration with a lead on there and actually getting it closer to zero, it was way off on you. 0.07 wasn't a big deal for me this time. I just wrote it down and I'll subtract it accordingly, but either way, you can do it either way. It actually worked quite well. Going up in just the order of expense, we'll go to this little MESR100, just a straight ESR meter. So we'll cut this on, make sure the display shows up okay on camera. I believe it's better down than up. Yeah, I think the glare is worse the way my lighting is. We'll bring in the big 2200, check it. And it auto ranges to the 0 to 1 ohm range and shows 0.01 ohms. And it tells you it's good for a cap with low ESR, but it's referencing a 25 volt electrolytic cap. So that's the only thing, is you got to watch what it's referencing. Just because it says good, it may not always be good. One thing I failed to do was I meant to show you the 0 first, which is still dead on from earlier when I did it on the video. We'll go through and check the 560 microfarad. It's showing good, 0.027. We'll go to the one that's the known failed capacitor. And it shows, you know, from the 10 to 100 range, it's OL, overrange, overload. It's actually showing that it can't even read it. It said it was reading as overflow, so letting you know something's definitely going on there. Didn't pick up a circuit at all. .010 or .016, showing that it's good. Oh, I didn't have a good connection on that one actually. You may have saw it on the camera moving before I did. Shows good. In circuit, we'll bring this board back in with a 2700. Shorter leads can be a little challenging, but Like I say, in the long run, especially at 100 kilohertz, you want it to be as short as possible. It's showing good. We'll go ahead and check this little one like we did with the 328. Small one's going to show a higher resistance. .541. And then we also did this one with the 328. And it's showing .010. You know, overall, this meter's quick and handy. It does a good job. Now, one thing you may have already noticed that's a problem to me with this meter. I knew it when I bought it that it was simply an ESR meter, but for the money, it wasn't a bad deal. It's not a bad little meter. But you can buy the capacitance meter or the ESR meter. I do prefer to have them both in one because it really does matter. You're looking for almost a dead short, but if your capacitor is shorted, it can almost show good. So you got to really watch that. I really learned over the years that I like one that we're fixing to come to next that shows the capacitance and the ESR together. All the rest of them here today do. They do just that. So we'll get into one of my favorites here, the little peak. Go ahead and hook it up. One thing about this peak is it's also hands off. Once you cut this on, it'll show analyzing. It'll read the capacitor. It usually gives you ESR before it even has time to fully rise on a large capacitor. Depending on the value, it's going to take a little longer, but I mean, right off the bat, it's quick. 1958 and .02 actually shows the capacitors in spec. .06 ohms. See if it'll pick up the bad one. Oh, open circuit or low capacitance. I think it's both. Took a while. This is the high value capacitor, 0.05 ohm. To me, it's a big help to show the capacitance value on screen without having to go back and check them when you have a low ohms reading. Here we go to 2700. .01 at 2446. I can do the little one on this one too, I forgot. And these little alligator clips do grab good on these leads. Even on the board, I can let them go at 0.66, 51 microfarad, good deal. So, last but not least, since we are doing a comparison, try to do them all. It's already telling us 0.02 on the ESR. 7962. And being an in-circuit test, we did it quick. All right, well, this by far is one of my favorites so far. But next we bring in the high dollar job, and surely it's better. Well, maybe. I'm gonna try to make this as quick and painless as possible, because this meter here has a lot to it. So I want you to see the features of it and compare it with the ESR reading of the other meters we had today. But I guess it's so feature rich that it can be a little bit time consuming to explain a lot of the functions of it. But one thing we had talked about is the different frequencies, the parallel to series checking. So just to mention that the book tells you it defaults to parallel on the reading for the ESR, and it says in capacitance both. It reads both. You can have a sub menu, so you got the main and then the secondary display. So we'll have capacitance, and then we'll have the ESR up top in the smaller font. But it defaults to parallel, and you'll see PAR on the screen, and then if you hold it down, it'll go to series. They recommend series for more of inductance, and they recommend the parallel for capacitance and resistance. So just checking out a circuit, you would think you would definitely use parallel, but you kind of got to play around with it and see what works the best. And also, they recommend anything that's less than 0.01 microfarad, which we don't have anything like that today. They like use 1 kilohertz signal to check it. But they're actually saying anything greater than 10 microfarad to use 120 hertz, which is a little bit odd, as we mentioned earlier. But all the rest of these meters, well, with the exception of this one, uses 100 kilohertz. So, and that's typical of an ESR meter, is to use 100 kilohertz, because I think that's what the factory of most capacitors rate their and base their ratings and specs of capacitors on. So we're getting into this one. We'll cut it on. Go to capacitance. Oh, it's already on capacitance. And we'll go to ESR. We'll short out the leads and do a check. Actually, let me see what frequency this is on. 1 kilohertz. But let's go to the 100 or 120 kilohertz. I mean 120 hertz, I'm sorry. And then let's leave it on parallel. That's what they kind of recommend for checking in our range. And we will take these little leads and there we go. Turn this to the right polarity. And it's showing 1.88 millifarad or 1880 microfarad. So, but the ESR is 0.039 or so. Actually showing like this capacitor may be just a little bit out of tolerance on the ESR. But now the peak actually showed it to be within tolerance. Without looking the exact specs up of that one, that's really close to the tolerance. .506 and 0.086. Showing just a little bit out also. What I'm going to show now, before I go much further, I'm going to show the difference in the series hold it down and go to the series. .039. I know on some of them it showed a good bit different being in series than it did parallel. 0.08. Let's check the bad capacitor with it. Showing into the nanofarads and absolutely no reading of ohms on its scale. So definitely picked up the bad capacitor. That's every one of them we tried today did pick up the bad one. I wish I had more bad ones still around. I usually toss them. I don't really think about saving them. .026 and 7.3 milli. Now let's try some in circuit. Here's that 2700. See, it does matter about polarity on this one. .345 milli and 0.0185 ohms. Shows good. That grabbed pretty good. That's not quite gonna stay. There it goes. Almost 46, 45.6 microfarad, 1.65, that's good. And last but not least, it's showing 7.39 milli and 0.036. Shows good. So summing things up, every meter here from the least expensive, less than $20 category, up to the $250 to $300 category. Every meter here, ESR wise, actually checked in circuit and out of circuit capacitors. Relatively across the board the same as far as a pass and fail measure. This one only checks ESR, but still they found the only known bad one. They showed us the ones that were on the fence, kind of borderline, but they all showed that it was about borderline, which on the higher range of things it does get very low. So this is price wise. If I was to maybe rearrange these to be in the most useful, maybe the most useful, the easiest, the ease of use and the most reliability and quick of testing would probably still be in this order. I mean, both of these are made where, and this one as well, just checking ESR wise, this one is just as easy as any of them for checking, ease of checking. But just the fact that it's only an ESR meter and don't show capacitance as well while you're testing for that reason, it's always going to rank a little low. This one has such a high-end use for other things, but just for strictly board checking, electrolytic caps, switch mode power supplies, and things of that nature, where you're just looking for the ESR, I really don't go to this one that often. It's a little bit tedious. You have to play with the frequency and where there's parallel and series, and these here just work. So this is really my go-to. I really like the little peak. It works well. The leads are nice. The clips are good on it. I'll just talk about the good things about it for a second. The auto discharge is really neat about it, because in circuit, whether it has a bleed resistor or not, it does a good job. The only negative thing about this one is it does take the little 12 volt, the 23A series. A little bit harder to get into with the 3 screws, but not a big deal. Not quite as easy as the rest of these to replace, which, you know, they all have some type of battery door and a screw. But with that said, this being the 60 to 70 being a better version with more features, the specs on the ESR60 actually state that it's a AAA battery. If that's correct, then the AAA battery would be a lot easier to come by. I do keep some 12 volts around for this, so it's no big deal to me. That's about the only negative thing I got for the whole thing, and it's not even an issue with the 70 series, the ESR70 model. This one again just ranked really high. Good little meter for the money, great to have around, well worth it. This one for the money, I think it's 55 bucks, not bad. Just if I had my choice, I would always have, like I say, capacitance showing. This one, pretty much do it all. It is kind of a pain. It ain't the easiest to set up and get ready, but it does have a lot of features I didn't talk about, like the record, the USB, so you can hook it to the PC for checking, charting. A lot of features in this one that we just don't need for this test. So with that being said, I hope these 4 meters comparing gives you a little insight of the ESR checks and maybe something to look for if you're interested in buying a meter, or maybe you already have one looking to buy another one. Hopefully you got a little bit out of this video today. If you liked it, please give it a thumbs up. If you got any comments, good or bad, please leave them down below. And please subscribe, and thanks for watching.